I hope the recording is going on fine. Admit. Yeah.
Uh, Maybe we can close it now. Then next time we can continue on that track because
Yeah.
things are confusing. Okay.
Yeah. Right. Fine. Next time when we talk about drag, so we can start in a structured way, like as per what the video goes. We can talk about it that way.
Yeah, yeah,
What is rag? What is not rag? Where to use rag? Like and the retrieval part, we can talk about keyword search,
yeah,
algorithms,
yeah,
semantic
yeah,
search, embedding models, then vector databases, why they are used. Then
yeah,
chunking we discussed anyway, but we'll come to it again. Then the whole RAG architecture, the RAG pipeline, like
yeah.
how the control flows. Is somebody trying to join? No, okay. All right. Then RAG architecture we can talk about, right? So that is fine. But is it, I don't know. Remember seeing some news which mentions that the RAG is no longer useful in the sense that we have some advanced technology which can replace RAG now. So there is no point reading RAG now. So do you know anything about that?
No, I do not know. Actually, even I
Okay.
felt that when I was starting with RAG, I felt RAG is very basic. Okay,
Yeah.
something different should come. That's what I was expecting, but nothing is there actually. But RAG is still a very basic thing. Okay, RAG is not something to use at the enterprise level, is what I believe. But all the enterprises use it because the cosine similarity is not something enough. Okay, or the chunking is not something a good way to cut it and do it. Even if you want to do it, you should be doing it with some semantic chunking with I would say with the transformers and all, but those things are costly. Nobody is doing that, but
Hmm.
it works. It
Hmm.
works to an extent. Okay,
Hmm.
so that's why people are using it.
Hmm. Hmm.
So I don't know if there is anything coming. I do not
Okay.
know. Vector DB, instead of vector DB, there is a knowledge graph that is coming, but I don't know. Tag.
Oh, maybe that is what I heard. Vector DBs are no longer required, and maybe knowledge graph.
No, no,
Uh,
knowledge graph again you can use it in the use it in the RAG itself. Oh yeah, yeah. Some people will say, okay, knowledge graph will kill the RAG, but it is just a replacement for the vector DB, man, not for a complete RAG.
then maybe
RAG is
vector
not
DB.
just yeah, yeah. I also have seen those kind of videos who
Oh,
say,
okay.
okay, RAG is dead, knowledge graph is coming, but that's not correct.
Okay. So vector DB is just for what you say, man. For faster searches. That's it, right? That is the whole
Ah,
agenda of by
no,
index.
no, like
It can do
indexing, yeah.
else we have to go search all the vectors if you don't have vector DBs. But if we introduce vector DBs into the play, then because of their indexing feature, we can only search a cluster of vectors instead of the whole vector space. Correct?
That's correct, but that is not done by the vector DB actually. There is some algorithms
HNSW
called
proto.
HNSW,
Uh,
especially HNSW actually. So
hmm.
they use HNSW internally. That's how it is faster. But there are other things are also there. Like say like different
Indexing
vector
mechanism.
DBs. No, different vector DBs can use different mechanisms, not only HNSW. There are something IVF and PQ. Okay, I
Yeah.
forgot they can use those algorithms. But HNSW is the famous one. But there are, I mean, totally there are three.
Yeah, I
Okay.
can see inverted file IVF is one like you
Invert,
mentioned.
huh,
Then one is
yeah.
LSH, locally sensitive hashing.
I don't know about that, but I know about one more PQ, I think. I
PQ.
forgot what. PQ, I think.
Okay. I mean, the famous vector DBs which are mentioned are Chroma, which we usually use locally for our own testing and learning
No,
purposes.
Chroma local, yeah,
Yeah,
not enterprise.
Pinecone is the
P-
industry standard, I think,
ah,
where
yeah, PG vector is there.
they handle
PG
like
Postgres.
Yeah. Oh, is it
Post,
what? What is that? Fine code?
Postgres.
Oh,
Postgres.
okay.
Postgres has a vector DB also.
Oh, I didn't know that.
Yeah. So that is also good. Pinecone is there. Yeah.
Then it is all about scaling semantic search with vector DBs. They are only used for, I mean, the whole point of using vector DBs is to scale the semantic search to make it more
Mm.
efficient. If you have more data, right,
Mm.
you have more vectors, then looking only at some specific vectors is what, with the help of indexing,
But
vector
that
DB.
is no, that is not with the vector DB. That is with
Indexing.
that particular algorithms, HNSW
Yeah.
algorithm. But
Oh,
vector DB is to store all the vectors together.
okay. If you don't use indexing, then it is again the same problem. But indexing helps us to focus on specific vectors
Ah,
instead of the whole. Okay.
correct, correct,
Great.
correct.
I
Yes.
think, yeah, that is, we can talk about RAG next time in the next lecture, right? And then, I mean, yeah, prompt engineering is anywhere everybody knows. Then fine tuning and RAG, these are like they mentioned, like three
Mm.
best methods are there to better your responses. One is prompt engineering, like providing the right context in the prompt, and we all know about that
Mm.
stuff.
Yeah,
One is
yeah.
fine tuning. Okay, one
Mm.
is this RAG.
Yeah.
Fine tuning is used, if you correct me, Pavan, fine tuning is used for data that is static. Okay. It can work the best. It works the best for data that is static. For example, suppose Oracle has to design, say, a policy co-pilot, like the video says, okay. And we
Mm.
want the co-pilot to respond in Larry's voice, the way Larry speaks. So we take a
Mm-hmm.
model, we train the model on
Mm.
Larry's mails, articles, news
Mm.
events, videos,
Mm-hmm.
audios,
Yeah,
whatnot, so that it
yeah.
catches on to that and behaves exactly the way Larry speaks. Okay. So,
Correct, correct.
so that is static data. Larry cannot change the way he speaks, the way he
Yeah,
intonates, the
yeah.
way he
No,
modulates
that's correct.
things. So for
Yeah.
static stuff, fine tuning is the best. But if you
Is
talk
it
about,
uh, is it the word static? I don't know. Oh,
I mean,
correct.
static,
I understood, but whatever you said is correct.
but
Because
static, I don't know is the
static,
right word.
yeah, static means something else actually.
Oh, is it? I don't know. So that's the problem. I mean, for data that is
In
not
some
changing
other,
frequently, so you use fine tuning for that.
no, no, I think it is like this. My professor said it in a very good way, which I completely forgot. Okay, sorry for that.
Remember the emotion.
But
Okay.
yeah,
Okay.
the thing is that when you want to, you don't want to, you don't want the LLMs to learn the facts, especially those facts which are keep changing and all. Okay, the kind of news and all. Okay, that keeps changing, right? You don't want to make the this one learn. What you want the LLM to learn is something behavioral, which won't change. Something like maths, okay, which won't change. You are doing a plus or 2 plus 2 is always equal to 4 kind of thing, okay. I'll watch the video and come up with that exact statement, okay, how what he said. It is
Hmm.
nice. It is.
Okay.
Let me think if I can remember.
Like behavior is what you told, right? I mean, the way
Yeah,
somebody
yeah.
speaks, right?
Correct. You
That is
want
what,
the LLM to behave in certain way,
yeah,
okay?
which is
That
fixed.
is say this one. One thing is that this one there are different LLMs, okay? The starting LLMs were not like you can't answer the starting LLMs were like you give the word, it will give you the next word, like it will fill in the blanks kind of, okay, or even the middle blanks also it can fill those kind of LLMs. Now you want the LLM to learn to answer the question,
Hmm.
right? That is GPT. That is instructor tuned LLMs. Okay, that is called instruction tuned LLMs. So that LLMs, those are the things you tell the LLMs to behave. Like you need to behave. When the question is answered, you only answer the answer. You only give the answer. Okay, not like you just fill in the next word, and all.
Hmm.
Okay, you understood, right?
Yeah.
Those behaviors are done. I mean, fine tuning is used to introduce those behaviors to the
Oh.
LLMs.
Okay, so you're
Okay.
saying to train your LLM to say not only the next word of suppose I ask a question, don't say a next word
Mm.
that can come after the
Mm.
question, but answer the whole question. To make
Yeah, yeah.
LLM behave that way, they're fine-tuned with that kind
Right.
of data to behave it that way.
Right.
Correct? That is
Right.
the whole point.
Say one other simple this one. Let's say one LLM is there. Uh, I mean, this is not, let's say small LLMs, okay, because big LLMs are more intelligent. It always plainly answers the question, okay. Plainly answers the question. But we want it to be nice. Okay. We want it
Hmm.
to say that, okay, thanks for asking this question. And very nicely it should answer. Okay. We will train for that.
Yeah,
You understand, right? We will train it for that. That
correct.
is where fine tuning is helpful.
To add
Okay.
behaviors, like to be
To
more
add behaviors,
courteous, be more thankful,
add,
be
yeah,
more
add
positive.
structure.
Yeah, yeah.
Correct, correct.
Right. Okay.
Yeah.
To add behaviors to the LLM. Okay, good.
Right,
That's a
right,
good
right,
example, right? So that is where the fine tuning comes into picture in reality. Like, okay.
right. But RAG will never replace the fine tuning, or fine tuning will never replace the RAG. They both
Yeah,
are completely different.
use case. I mean, RAG is used for data that is dynamic, that keeps on changing. Like the policies are there, you train, you add, you take the policies, you create the embeddings, the vectors, and you store it in a vector DB that is there. But
See, more than you can think like this. RAG will give you the grounded answers. Okay. But say you
with citations, it can give
with
you
the
answer.
citations also, no, forget about citations. You get the grounded answer. For sure, you will get the answers from the real documents.
Not
Okay. But
hallucinations.
what not hallucination. But if you fine tune the LLM with the same documents also, it need not be answering the exact same this one. Okay. So when you fine tune your, there is no memory to store those documents. Okay. It is just changing the weights. Okay, saying that, okay,
Ah,
this word comes after this word, this word comes after this word. It's just based on the probability. So you won't get the grounded answer. Even if you fine tune, you won't get the grounded answer. That's why you should not uh, train the LLMs thinking that, okay, I will train on based on these facts and these facts will be returned to me when I do the inference. No, that's not going to happen.
hmm.
So it will hallucinate actually. If you're asking for the facts, LLM will hallucinate.
Okay, so you are, yeah, so you're saying when you say grounded answers, you mean the one that is based out of facts, documents, and not hallucinations, right? So
Yeah,
if you
yeah.
fine tune it, you may get hallucinations, but
You will get
if you
hallucination.
use RAG,
Say
then you will get the right data. Okay.
say one way to think is like this. Okay, so you a company trained an LLM with all sensitive documents and sensitive information, including passwords, secrets, everything. Okay, so now that LLM somebody stole, it just waits, right? They stole it. Okay, now what will happen? Is it a security risk?
It is.
Okay, so what?
How will this, how
What?
will this steal it if you train the LLM with that sensitive data, for example, right?
And
That
they
data is
saved
not
that
stored in
LLM
any
somewhere.
memory or anywhere. No, uh, it is,
Ah,
yeah, I mean,
correct.
okay, what I'm saying is even if you train the LLM, fine-tune the LLM with company's sensitive data, right?
Ah,
And then that data which you trained it with doesn't remain in memory. It is just, it changes the way it behaves and answers the question.
correct. They wait. Now
What
that
is,
weights, and
yeah,
now that weights are stolen. Okay.
okay,
Right?
you tell me first what are weights? Okay, I don't know what are weights.
Okay, forget about weights.
Okay.
They trained, one company trained the sensitive data to an LLM. It trained an LLM with the sensitive data. Now somebody stole that. Company two stole that LLM. Okay, from the company one. Now can company two get all the sensitive information of the company one? Okay,
Not this,
using that LLM.
not necessarily, man.
No, they can ask, right? What is the question?
But
Okay, or do you?
But when your query goes right, you
Ah,
can
ah.
train the model at the same time not to respond with the sensitive data as well, right?
No, no. You plain LLM. Okay. Plain LLM is
Just trained the
trained.
data and stole
Trained with
over.
trained with the plain LLM, and LLM is not trained to say I will not give the sensitive data and all. Just trained with the plain LLM. Now the company two got the that LLM. Will company two get the full sensitive data what company one
No,
had trained? Actually, the
no,
answer is no.
no.
Okay,
Yeah.
but it is not completely no. Probably 10% of the sensitive data can be inferred from that LLM. Okay, you can
Hmm.
ask the question, sir, can you give me this password? Okay, it may give the password or it may not give the password. So
Yeah.
what my professor said is that maybe around 10% of the time you might get those sensitive data.
Hmm.
Okay,
Very
because
less
again it
probability.
is this one. So you can't fine tune the LLM thinking that you will get the exact same data back.
Yeah.
For that you need to use the RAG. If you
Right.
want grounded answers, you need to use the RAG. If you
Hmm.
want the behavioral answers or behavioral changes, then you will go for the fine tuning.
Hmm. 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 Okay. If our next time you cover this weights and
I will watch some videos and come. And I'm not good at remembering the things.
okay,
When
okay.
I go back, I'll remember everything. But if I'm
Okay,
yeah
okay, sure, sure. Take your time and then we can talk about it. Um, uh, right, and I had this question like just trying to compile a question in my head based upon what you said. Okay.
yeah.
You mentioned yeah, when you fine tune the LLM with the data, right? You change the way LLM behaves, right? But you don't have the data with you after training. It is not stored in any memory. It is not there,
Mm-hmm.
right? It just changes
Mm-hmm.
the way the LLM behaves. So that is fine. Now, the
Mm-hmm.
way LLM behaves, how that behaviors which LLM is gained by fine tuning, where is that behavior stored internally? Behavior
It's not
stored.
stored actually. It changes the weights. So when the weight changes, those behaviors change actually. So for this, you need to understand the this one man deep neural networks. It's very interesting. So
Hmm.
it is like a human brain. Okay. So human brain has a memory also, but the thing is that uh, how do I say? It all the things, whatever your behaviors are stored in the neurons, right? Not in the memory actually. So you don't think, okay, I should do like this and then do it. It just comes out actually.
Yeah, so okay. So there is no memory involved in fine tuning after it has been fine tuned and trained. So it just
Memory is not
becomes
involved in, yeah, memory is not involved. Yes.
okay. Okay. I was like, there should be a way. I mean, okay, maybe
It's it's
you can.
all probabilities, man. It's all probabilities. It's all probabilities actually. So the best thing to think is like this. No, maybe you actually go through the deep neural networks. It is good.
Maybe that.
Otherwise, you can. I mean, I don't know if you can think of it now, but deep neural networks is, or even the LLM is like a universal approximator. Okay, that is the one word for these things. Even the brain is like a universal approximator. Okay,
What is
so
that?
you get trained. Now, how do I explain that? Because see, you have a coding some application, right? You input A and B, you get the output C. It's very deterministic. You input B and C, you get D or something. Okay, it's very deterministic. So you you send few inputs. Okay, here the output is deterministic in the coding application. Okay, but now you can build a system where you will try to get the same output, but not by coding, but by approximating. If you put these two inputs, oh, this might be the output. If you put these two inputs, okay, this might be the output. So you you assume Okay, you assume and give the answer. Not that is where it
Calculating.
becomes probable. It might give the correct output or it may not give the correct output. Okay,
Hmm.
so that is where the deep neural networks comes. It assumes and or it approximates. Okay, if you put these inputs, it approximates it to certain value as the output.
Hmm. It
So
is
that
not
is what
doing
it
the
is.
math, but it's actually predicting based upon what it has learned from the two examples. Okay. Hmm.
Right, right.
Hmm.
Yes.
Hmm. 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 Okay. Fine,
Oh,
Pavan. Think
okay, man. We
we are good.
will close it now and we'll maybe probably next week we can meet.
We'll schedule it. But you give some content for us to read and come.
Depends on you what you want, man. Because see, these deep neural networks and all, you usually don't get it in the interview. I mean, I don't know how the interviews goes, but
No, but
I think you'll not get it.
those,
Nobody knows it first of all, actually.
yeah,
Okay,
nobody
honestly.
knows it with that depth, right?
Yeah.
Unless you do live with
So
people and research. Yeah.
I would say if you are looking at normal development job, testing job and all, I think it's mostly about the RAG, how it works and all, and the agents, how it works and all. Probably that, like Arun said, the lang chain, lang graph, all those things, and something like agents, how agents will collaborate, all those things. Then now the things what are coming is this skills, cloud code skills and all. Okay, cloud code
Yeah.
skills, code access skills, all these things.
Yeah.
I think that's all I know actually. But maybe if you come to know something additional, let me also know because I have not attended any interviews or not planning also. So I do not know. Maybe I can ask somebody. If I'll ask in my MTech group, how is the questions and all. Since you are not looking at the data science side, so obviously you'll not get the questions on data science or ETL, ELT, all those things. So I think mostly you will be on these agents, cloud code skills, MCPs, and RAG. I think these things are only now.
Yeah.
Most probably these things only.
So what do you want to pick up next next topic? We can think and come back on the group. That's fine. Maybe
We
RAG only.
can
Some
finish the rag. We can finish the rag, and then we can take this skills or MCPs also or agents also we can take.
yeah, I can also help with the
Yeah.
agents and MCP.
Yeah,
I can also help,
that we can take. Yeah.
right? So yeah, RAG, whatever is mentioned in the video, apart from that, if you have anything, if you have more solid stuff on that, so we can talk about
Ah,
it and you can share the
yeah.
material, we can go over
I
it.
need to go through I need to go through the things once actually. Uh, I'll probably next week or next week meet something like that.
Yeah, yeah,
Means not next Sunday or something like that. Next Saturday.
yeah.
Uh, Depends whether I can go through the video, but I'll try. Okay.
Yeah, I'll also prepare about agents, maybe some examples in case.
I would no. I mean, just because I mean you are kind of not having job now, right? Just in case if you are interested, you can still go with the my lecture videos. Okay.
Do
So
you
I
have
mean, I
lecture
don't want
videos on other stuff,
no.
agents, latest stuff, like which companies are
No,
asking,
no.
like only the code stuff, right?
Only the core stuff. Yeah, only the core stuff.
Then maybe RAG,
Don't.
maybe RAG I can start. RAG is still relevant at least,
Yeah, rack is there, but mm,
because in
no,
MCP also.
what I'll do is that I'll try to share it. You see it. If you think you can continue on that, you can do it. Otherwise, it's okay. You can have the other this one also, because it's mostly it's not interview directed course, right?
Then I
Uh,
shouldn't be. I mean, I should wait for getting a job and then going deeper into those things is what I'm feeling. Every hour is precious from the interview point of view to prepare for those things. Okay. So
yeah,
once I
yes,
am settled
because
into a job, okay, then I can go deeper.
Nobody knows those things at this industry at this moment. So only few people will ask those deep questions. I don't
Then
think so.
maybe
People will.
RAG is a good place because I remember in MCP,
Hmm.
we make available from the MCP servers, we make available to our agents three things, okay? Tools, resources, and prompt templates, okay? So tools is
Hmm.
anyway okay. Mostly tools are the is the most famous thing which MCP servers makes available to our agents, and agents can directly use the tools and do their work, improve their context. But this resources, right, that has RAG or in there RAG based resources are there which can provide more
Hmm.
context to agents to give better answers. So I think if I still have to, if we can stick to RAG and go deeper into different aspects of RAG, right, that will be useful for interview point of view also, and then learning also the content about AI, right?
Yeah, yeah, yeah.
Yeah.
I'll check that. I'll check on that sites and come.
Yeah,
Okay.
because you know the idea. Like you got what I know. You know what
Yeah,
I
yeah.
what I lag. I mean, all the deeper things like what are weights, what is temperature. I saw temperature somewhere, but I don't know what it is. I have to dig into that. But
Hmm.
things like that,
That's not.
which people
Hmm.
can ask superficially about LLMs,
Yeah,
about
yeah. Yes,
padding,
yes,
about vector
yes.
DBs. You make us ready for those things, right? Because everybody now who will join these meetings will have a job. I need to secure one. So maybe for a
Yeah,
couple of weeks we can align towards getting a job, and then I can get a job, and then we can focus into deeper concepts so that we can build some research level knowledge and build something good out of this, right? So
yeah,
some
yeah, yeah,
long term shot, okay, let's not play it
yeah,
aggressively and lose the traction in a few weeks only. We'll play week
yeah,
by week, test match, and gain some good expertise hands on, so that we can build something credible which we can use also, right? Because you never know what will come next. So
yeah.
gaining
Okay,
knowledge,
and
yeah, we'll do something about it.
yeah. No, I will drop off now. Okay.
Yeah, man.
And one more thing. Okay, we'll just keep this max 1.5 hour. Okay, we will cut it down
Yeah.
at 1.5 hour. Otherwise,
Yes.
it becomes too much actually, and
Yeah, yeah, man.
uh, drains of some energy also.
I know, I know, I know. We'll keep it 40 minutes is one this thing, so we can do
No,
it in.
I'm saying 1 hour is one thing what we can do it. Then we can do it frequently actually.
Yeah,
But even if the discussion goes, we'll keep it till 1.5 hour. Hard stop we will do.
yeah.
Okay. Otherwise, what happens is that like Murray dropped off. Like people will also drop off, and it's a bit long also, right?
Yeah, and we'll not get people engaged on this for longer time. So keep it
Correct,
crisp,
correct,
keep it
correct.
professional, and wrap it up in an hour.
Yeah,
That should be good.
yeah, yeah.
All right, man. Cool, Pawan.
Okay,
Carry
man.
on. Thank you for your
Okay,
time. We'll
then.
catch up later. Okay.
Sure, man. Yeah, thanks.
Hello. Bye, man.
Bye.
Thanks.
Yeah.